The Fibonacci sequence is one of the fun things in math that every math person knows and a lot of other people could really benefit from knowing about. It's pretty simple. You start off with this 1 and then another 1. And then each number after that, you just add together the previous two. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21, 13 plus 21 is 34, and so on infinitely much, however much you like. Now, there's some pretty interesting stuff about this sequence, but one of my favorites is what happens when you divide the numbers. For example, if we come down here and we divide each subsequent term by the previous one, 1 plus 1 over 1, and then 2 over 1, 3 over 2, 5 over 3, 8 over 5, 13 over 8, and 21 over 13, and then 34 over 21. We can put each one of those in a calculator and get its decimal equivalent. So as you do this more and more, these numbers approach a specific fixed quantity. At first, 2 and 1.5 are pretty far apart. This is a little closer. These are pretty close. These are really close. These only differ by about 0.01, and these are even closer than that. So the fun thing is you can calculate these with this repeated algorithm. This one is just 1. This one is 1 plus 1. This one here is 1 plus 1 over 1 plus 1. And keep doing that. At each point in the sequence, what you're going to do is take the last number you wrote, and you're going to replace that with divided by 1 plus 1. So keep doing this. We'll come down here so we have more room. 1 plus 1 over 1 plus, now replace this one with 1 over 1 plus 1, and keep going. 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus 1. It almost has the feel of a chant after a while, doesn't it? Let's just do one more. 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 plus 1. So if you actually put these in a calculator and you get all your parentheses right, or you do them in a number of steps, you can correctly identify that this equals 2, that equals 1.5. This is going to equal 1.667, 1.6, 1.625, and so on. Now, the interesting thing is that you can keep doing this infinitely many times, and if you do that infinitely many times, 1 plus 1 over 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 1, infinitely many times, what you get is a number called phi, the golden ratio. And the golden ratio, as it turns out, is just equal to 1 plus the square root of 5 over 2. And this is known as the most irrational number for reasons that are kind of complicated and I'm not sure I fully understand. But the point is that this Fibonacci sequence has a lot of implications for geometry and plants. I'll post some videos in the optional material which go into this in much better depth than I can, but these numbers relate to the spirals you can see in things like pine cones or the face of a sunflower or things like that.